Hi everyone, let's solve this problem. Edit distance. Given two strings, word1 and word2, return the minimum number of operations required to convert word1 to word2. You have the following three operations permitted on a word. Either insert a character, delete a character, or replace a character. That's what they have mentioned. So if you take these two words, if you check the operations they have done, first is basically they have kind of replaced h with r, and then they have removed r, and also they have removed d, and both the words are matching. So basically we don't really have to tell which operations we have performed, but we just have to return the operations, minimum number of operations required to convert word1 to word2. So that's the problem statement. So let's understand a couple of things before. Let's say for example word1 is ABC, word2 is ABC as well. The number of operations required is 0 because they are already same. You don't have to actually do anything. And let's say for example it's ABD, then in this case you will do one particular operation by replace, this is ABD and let's say this is ABC. We are going to replace this particular character to C so that the number of operations are 1. Let's say for example I have empty word1 and word2 has ABC. In this case the total number of operations will be equal to length of the word2, and vice versa. If I change this word1 as ABC and word2 as empty, the number of operations still are equal to 3 because we can delete all of these things. So now let's use dynamic programming to solve this problem. So for that thing we are going to use the same example which we have here. So we have HORSE and we have ROS. Okay, let's have a grid. So I'm just ensuring that we have a proper grid before, and now once let me draw more lines here, and so yeah, this is a grid, and let's consider this as a empty string. So let's say for example if we have this particular cell, if we have both empty strings, then number of operations required are 0. That we are very sure of. Now in this particular position we have all 5 characters, like, so how we are doing bottom up. So in this case we have all the characters, 5 characters, and we have empty string for word2. So in that case our number of operations required from going 5 characters to empty characters is just removing all the characters, right? Same thing with respect to if I am at this particular position, I have an empty string in the word2. Okay, let me also mention word2 and word1. So now in this case, okay, let me use a different marker for mapping the values 5 and 0. So now again when I have this particular remaining characters and the empty string, again it will be length of the remaining characters here. So 4 3 2 1. So I'm just reducing the character count. Same thing with this particular thing. I have an empty string here, and if you see I have one I have all 3 characters, and so because of which the length will be, like, the number of operations is 3. Here it will be 2 and here it will be 1. Now when I am at this particular cell, E and S are different. So if they are different, what will happen is we have to do either of the three operations: insert, delete, or replace. So we can do any of them. So what we will do is 1 plus minimum of, let's call ABC. ABC are nothing but A is insert, B is delete, C is replace. I'm just writing it for the placeholder part. So minimum of all these three operations. Why do we need to take one? We are doing one operation and we are taking the number of operations required to take for the remaining string. So in case of insert, okay, let's say I have this particular, or let's say even, right. So in this case, if these two are not equal, so we'll inserting a character. What will happen if I have to insert? This is I, let's say this is J. If I have to insert a character, I will be inserting a character into word 1, right? I'm going to, like, all the operations will happen on word 1, so I'm going to insert the word like character into the word 1. That means this particular character is inserted and it will be similar to whatever character is present at the ith position, so I can easily move on with J. So if I am inserting, that means it will be I comma J plus 1. Let's say, for example, instead of inserting, let's say I have only AC. Now let's say I am at this particular position and I am at this particular position. Let's say I have to delete this. So if I have to delete this, what should I do? I should just move my ith position, I plus 1. J will be same because once I delete, I move my I pointer. Still I have to compare the characters, so it will be I plus 1 comma J. For the replace part, so let's say we have a replace thing. I'll just take one more example to explain the replace part. Let's say ABC, ADC, right? So I have J here, so I have to replace B with D. So if I replace it, I will be definitely replacing with the D character only. That means D and B will be matching. So basically B will be replaced to D and D and D will be matching. So I also has to move forward, J also has to move forward, right? So replace will be I plus 1, J plus 1. So if you see here, this is nothing but I comma J plus 1. This is nothing but I plus 1 J, and this is nothing but I plus 1 J plus 1. So these are the three cells which we are going to check if the characters are not equal, and we are going to take the minimum of them. So now here minimum of 110 will be 0 plus 1, it will be 1. And now in this case, E and O are again not matching. Minimum of all of this is 1. 1 plus 1 is 2. And then again we have all these characters and we just have E here, and R and E also not matching. So minimum of all of this is 2. 2 plus 1 is 3. We will move to the next cell here. S and S are matching. That means if they are matching, we don't really have to do any operations. That means whatever was the previous substring, like let's say for example, if both of them are matching, I and J, I don't have to do anything. I will just have to move to the next characters, and let's say this is D. So in this case, whatever is the amount of operations needed to like convert the first word 1 to word 2 is placed in I plus 1 and j plus 1. So now in this case what will happen here is that it will be 1 directly. We are not going to add any operations because they are same. We are not going to do anything here. S and O are not equal, so we will take minimum of these three, 1 plus 1, so 2. Again S and R are not equal, minimum of all of this is 2, and we are going to add 1 to that, it is 3. So now again we will move ahead, and then R and S are not matching, so minimum of all of this is 1, 1 plus 1 is 2. And again here not matching, minimum of all of this is 1, 1 plus 1 is 2. Same thing here, but they are matching. If they are matching, we will just take the value from the previous substring comparison. We don't really have to do anything about it. And then S and O are not matching, so minimum of all of this is 2, 2 plus 1 is 3. And O and O are matching, so I'll just take the value present at this particular position. O and R are not matching, so I'll have to take minimum of these three cells. Minimum is 2 and 2 plus 1 is 3. And then I'll go to this particular cell, and H and S are not matching, so minimum of all of this is 3, 3 plus 1 is 4. And O and O are matching, so I'll just copy the value from here. So H and R are not matching, so I'll take minimum of all of these values. It's 2, 2 plus 1 is 3. So our answer is in DP of 0, 0, right? And we also have to take extra cell to represent empty like empty string for word 1 and word 2. And if they are equal, let's say in this case when they were equal, we will just take the minimum number of operations required for both the substrings of word 1 and word 2. If not, we have 3 operations: insert, delete and replace. Each of them has their particular cell values. We'll take minimum of those 3 values and we will add 1 operation. So let's write the code for this. So in this case we will first let's first declare length of word 1 dot length, and let n is equals to word 2 dot length, and dp is, we are going to declare a 2D array, so length will be m plus 1 because we also have one more extra row and column, and new array of n plus 1, and we will fill all the values with 0 initially. Then I is equals to 0, I less than m, I plus plus, dp of I comma n is nothing but m minus I. So if you see here this particular thing, so what is the value of m? M is word 1 is 5, 5 minus 0 is 5, right? Again if I am at this particular position, this is 1, 5 minus 1 is 4. So we are going to fill that based on that logic as we discussed, and same thing will happen for this. So let's write code for that. This should be for and let, and this should be for let j is equals to 0, j less than n, j plus plus, again dp of m j should be equal to n minus j, whatever we discussed so far. Now we are going to iterate from I is equals to m minus 1, I greater than or equal to 0, I minus minus, we are going in the reverse direction, and same thing will happen for the column as well. J is equals to n minus 1, j is greater than or equal to 0, j minus minus. Now in this case what will happen is we have to check if word 1 of I is equals to word 2 of j. In this case we will just have to do dp of ij equal to dp of I plus 1 j plus 1. We are just copying the number of operations that is required for the remaining characters, leaving the characters which are same. Else, so we have insert op, delete operation, const replace operation. So for the insert it is dp of I j plus 1, dp of I j plus 1, dp of for delete it is I plus 1 j, and for replace it was dp of I plus 1 j plus 1. Now we have to update our dp with 1 plus mat dot minimum of all of these values. So let's say insert op comma delete op, and then again I'll have to take one more mat dot min operation for replace. So basically I'm taking minimum of all of these three. This is just the syntax of it. So it's done. So at the end I will return dp of 0, 0 where our answer lies. So let's try to run this code. Let's submit it. Cool. I hope the solution is clear, and now let's understand the time complexity of this solution. Time complexity of this solution is straightforward, m into n, because we are iterating over m cross n. Again this is m plus n plus m cross n. Overall it will be m cross n, and the space complexity is for the dp array m cross n. I hope all the things are clear. Thank you.